So looking at chemistry calculations, the first step is to look at mass, moles and GFM and using the simple triangle to help with these calculations. If you have a look in your data book, on the first real page of the higher one, you'll see there's lots of different equations, and these are all the ones you need, and you get your data book in your exam. So here we've got number of moles is mass over GFM. So to turn this into a triangle, we've got our number of moles, our mass, and our GFM. Number of moles is mass over GFM. Now, if we're looking in terms of units, the units for moles are just moles, it's just the number of moles. The units for mass are grams, and then GFM, or gram formula mass, is the number of grams in a mole, so it's grams per mole. So to calculate the number of moles present in 1.6 grams of oxygen, so what we're looking at here is, again, we've got mass, moles, and GFM. Sorry, not great at writing on this. So for mass, moles, GFM, we know the mass is 1.6. We know we can always work out the GFM. So for oxygen's O2. So again, in our data booklet, if you've forgotten, there's a relative atomic mass of each thing. So we've got oxygen here is 16. So it's O2, always O2, as oxygen's diatomic. So its GFM is quite simply (32 grams). 2 times 16, so it's 32 grams per mole. Now, to work out then the number of moles, we now know the mass and we know the GFM, so we can do N is M over GFM. So we've got 1.6 divided by 32, which gives 0.05 moles. Got a bit messy. And remember to write your units in, so moles for that one. So we can use this triangle to work out any of the things within the triangle. So next example would be calculate the mass of 0.05 moles of water. So again, we've got mass, moles, and GFM. And this time we know the mass. No, we don't know the mass. Sorry, we're trying to find the mass. We know the number of moles and we can work out the GFM. So for GFM of water, water is H2O. So again, in your data booklet, if you want to check, hydrogen is 1. So we've got 2 hydrogens, so that's 2. And oxygen is 16. So water's GFM is 18 grams per mole. And then to work out the mass, this time, because this is on the top of the triangle, we times the 2 bottom things in the triangle. So number of moles times GFM, which is this time 0.05 times 18, which gives us 0.9 grams of water. As our final answer. And again, you can do this to find the GFM. This is a bit more problem solving question when it asks you to find the GFM. So we've got mass, number of moles, and GFM. This question is telling us we've got 0.25 moles of an unknown gas. which has a mass of 11 grams. So we know the mass and we know the number of moles, so we can work out the GFM. So mass divided by number of moles, 11 divided by 0.25, and that gives us 44 grams per mole. Now, when it asks you a question like this and it's a possible formula for the gas, a good way to do it is to think about common gases you know. So for example, oxygen, we've just done in a previous example, GFM of oxygen is 32 grams. The next gas I would automatically think of is carbon dioxide. Carbon dioxide, let's check that one, CO2. So it's got 1 carbon, which is 12, and it's got 2 oxygens at 16 each, so that's 32, and altogether we've got 44. So carbon dioxide is a possibility for the gas. Now we don't need to know that it actually is carbon dioxide. For this question, it's a possible formula for the gas. So a possible formula for the gas could be CO2.